The exercise related to rate or a speed of a chemical reaction. The last session I have discussed the first three questions from this exercise. We'll start with question 4. A similar question is there, similar type of question you will find either we are collecting a volume of a gas or we allow the gas to escape and we collect and we measure the change in amount of the content in the flask, or sometime if a solid is formed as we did in the first part, first question, that sometime if a solid is formed, we record the time taken by the text or the cross to disappear. So the first part in question 4, a student investigates the rate or a speed of a chemical reaction between the lumps of calcium carbonate and a hydrochloric acid. The equation is given. Which measurement should the student make during the reaction to determine the rate? Because here he is collecting the volume of the gas. So how he can determine the rate? So rate will be actually equals to change in volume of a gas divided by time interval. So what two quantities he should measure to get the rate? Which two quantities? So what he should measure? Yeah, what he should measure? You can use a chat. You can use. That's good. So he can use a volume of. He can measure the volume of the gas, and he can measure the time. What happened to a rate of reaction as this reaction proceed, and explain your answer. Again, calcium carbonate is in excess, like it is more than enough. So a similar answer, like what happened to the rate. So rate always decrease with time. So never say, don't say rate is increasing. Like some students get confused by looking at this graph and they say rate is increasing. But this is wrong. Rate is not increasing. The volume of the gas is increasing. Rate is decreasing. Why? Because the rate is represented by the angle or the slope. If the angle is decreasing, it means the rate is decreasing. So what happened to the rate or the speed of a chemical reaction? A 3-mark question. So how you score 3 marks? First thing, you will mention rate of a reaction decreases with time. And why the rate of a reaction decreases? Because there will be fewer reactant particles. And eventually what will happen, the limiting factor, which in this case is hydrochloric acid or limiting reagent, will be used up. Excess one will left behind, like calcium carbonate is in excess, so it will left behind when the reaction stops. So the distribution of the marks, 1 mark when you mention decrease, 1 mark is for mentioning the limiting factor decreasing and used up, and 1 mark is for mentioning the fewer collisions, fewer reactant particles or fewer collisions are like fewer reactant particles or fewer collisions. And eventually the limiting factor will be used up. Student repeat the experiment at a high temperature. All other conditions were kept same. Student found that the rate of a reaction increased. Explain in terms of collision why the rate of reaction increased. A similar question, similar answer, structured answer should be there. What are the points we'll include in this structured answer? Number 1, like when we increase the temperature, what will happen? The energy of the particle or kinetic energy you can also mention. So same question, sometime 5 marks, sometime 4 marks, sometime 3 marks, but the answer is the same. So because sometimes they give each point a mark, some questions they give, so you have to write the structured answer. So kinetic energy or and the speed of the particles increase. Then what will happen? It will increase the collision frequency. Then what will happen if the collision frequency increase and there will be greater number of the particles having energy more than activation? Yeah, increase. There will be more successful collision. That's right. So the distribution of the mark, first one mark, how the mark, because the marking scheme, that what is the distribution of the marks, you can see particles have more kinetic energy, that will score 1 mark. Speed increases or particle move faster, second mark. Even though they are related, but that will score the second mark. Collision per unit time increase or collision frequency increase, that is a third mark. And greater number of the particle have energy more than activation, that will be the fourth mark. Apart from using a high temperature, suggests two methods of increasing a rate. Like we can increase the rate by increasing a temperature, that is one method, or like one way. What else I can do to increase the rate? How I can increase the rate of this reaction? How the rate can be increased? So I can increase the concentration, that's good. And increase the surface area, that's also good. Like I can use a powdered calcium carbonate, or I can use a high concentration of a hydrochloric acid. So increase surface area. If we that's the same thing, increasing a concentration of hydrochloric acid, it will increase both things. It will increase the rate. Catalyst can also be used to increase the rate of a reaction. To increase the surface area or increase the concentration. So both factors will increase the rate of this reaction. Question 5. Rate of the reaction can be measured by using we collected gas syringe here and we collected the nitrogen gas which is formed. Result of this experiment are shown on the graph. How would the rate of a reaction vary with time? Again, a same question. What happened to rate of reaction? It always decreases. So sometime if you see this question, here it's a 1 mark. When you check, here it's of 3 mark. The same question, like part B. What happened to rate of reaction as a reaction proceeds? 3 marks. Here, how does the shape of a graph shows the rate of a reaction decreases? 1 mark. Here, describe the rate of this reaction changes during the experiment. 4 marks. So, same question, similar answer, structured answer should be there. Don't write the stories. So, how does the rate of this reaction vary? And why does the rate vary? Actually, they divide this question into two parts. Like, how does the rate of this reaction vary with time? So you will mention the rate of this reaction is decreasing, decrease with time. And why does the rate of this reaction vary? Because what will happen? The number of the reactant particle decrease. So there will be a fewer collisions or less collisions. That's why the reaction will be slower. Okay. So distribution of the mark, like the first part, it is of decrease 1 mark. Then second is number of the effective collision decrease or fewer collisions. And eventually what will happen as the reaction stop, it means a limiting factor or a limiting reagent used up. Reaction always stop when we have a limiting factor or a limiting reagent used up. The reaction is catalyzed by copper powder. Sketch the graph that for the graph for catalyzed reaction on the same grid. And why a copper powder is more effective as a catalyst than a single piece of a copper. So because copper powder will have a large surface area, even if we change the surface area of the catalyst, the reaction will be faster. Even if we change amount of the catalyst, the reaction will be faster as well. Like if one reaction I use 2 grams of catalyst, another I use 4 grams of catalyst. The 4 gram of catalyst, the reaction will be much faster than 2 grams of catalyst. But the final amount of the catalyst or final amount of the product does not change. So if we use a catalyst, we have to sketch on the grid how that is part 3. So how the reaction is catalyzed. So this will be part 3. Write on the graph, label on the graph. And the last part here, why the copper powder is more effective. So copper powder will have a large surface area as compared to a single piece of a copper. That's why the reaction will be much faster. So even the surface area of the catalyst matter. Amount of the catalyst used also matter. In question 6, 3 of the factors that can influence the rate of a chemical reaction: physical state of the reactant, the light, and the presence of the catalyst. The first recorded dust explosion was in a flour mill in Italy in 1785. Flour contains carbohydrates. Explosions are very fast exothermic reactions. Use the collision theory to explain why reaction between particles of the flour and oxygen in air is very fast. So because it will have a like it is a powdered form, so as a result, what will happen? It will have a large surface area. Like fine powder, large surface area. When large surface area, greater number of the collision or a higher collision frequency. So when we have a fine powder, this will have a large surface area. And when it is having a large surface area, what will happen? There will be more collisions or more successful collisions or a higher collision frequency. That's why the reaction will be faster. Write a word equation for this reaction. Carbohydrates. So whenever you burn a substance which is containing carbon, hydrogen, and oxygen, so what it will give? It will give carbon dioxide and water. If we burn a substance which only contains carbon, then it will give carbon dioxide. So here we have to write a word equation. So we have carbohydrates plus oxygen, because oxygen support burning. So oxygen is always the reactant in a combustion. This will result in what? This will form carbon dioxide plus what? So they ask for word equation. As you can see here in the question, it's a word equation. So in a word equation, we don't have to write a formula of any compound. We just have to write the name of the substance. Is it clear? Question 6. Anyone having a question or a doubt till this point? A diagram of the apparatus which could be used to investigate the rate of reaction between magnesium and excess of acid. So magnesium is reacting with an excess of acid, it gives off hydrogen gas, and we measure the volume of a hydrogen gas in every 15-second interval. And the only difference in 2 experiments was method used to hold down the magnesium. The first one, we hold the magnesium, like we keep the magnesium down by using a copper. The second one, we use a plastic to hold. When we use plastic to hold the magnesium, like what does it mean hold plastic? Like we just keep a plastic here, so magnesium will not rise. But why the magnesium will rise? What might be a reason? Because when magnesium is reacting with a hydrochloric acid, as a result, it produces bubbles. So these bubbles will push the magnesium up. like fizzing a gas which is released here, that can propel the magnesium up. That's why to hold the magnesium at one place, we kept either we use a copper to keep the magnesium on the at the bottom, or we use a plastic to keep the magnesium at the bottom. What will happen if it rises? So the gas will propel and the magnesium will rise to the surface. So the reaction, because it will affect the rate of reaction. Why it will affect the rate of reaction? Because when magnesium rises to the top, some magnesium is inside the acid and some is outside the acid. So the reaction will slow down. We want to make a fair comparison. We want all the magnesium to react with the acid. Even what will happen if some of the magnesium is above the acid, eventually it will react as the amount of a magnesium is decreasing. So eventually all parts will react, but it will have effect on the rate of reaction. So why we want the magnesium, why we want to keep this magnesium at the bottom, so that like all the magnesium react at once all together. Instead, some is reacting first and then remaining part is reacting after it sink. So we use either a copper or a plastic to hold this magnesium, and we plot these results for a hydrogen gas collected. When we hold with the plastic, the reaction was slower, but when we hold with the copper, the reaction is faster. So in which experiment does the magnesium react faster? Which experiment? You can use a screen annotation to circle the experiment. Which reaction, in which experiment the reaction is faster? You can use a screen annotation to circle the graph. You can also use a chat or even a mic. The question is, in which reaction the reaction is faster? So when you check the final amount, like if you check the amount when the reaction was there with copper, so this was our graph, and now this part it appears it is a straight line. So mean the reaction stop here at this point when we are using a copper. But when we are using a plastic to hold the magnesium down, so reaction stop here. When the volume of the gas become constant, it means that moment the reaction stop. So when we use a copper, the line become horizontal in this part, so that it means like till after this part, the reaction has stopped. So means the reaction stop for copper, the reaction stop much faster as compared to that of with the plastic. So which experiment did the magnesium react faster? The answer is the experiment in which it is held down by copper. Suggest a reason why this experiment chosen in one had a faster rate. What might be a reason? Can you say a reason? Like why you think why this reaction is faster as we discussed? This is faster and this is slower. What might be a reason? What could be a reason here? Think about it. The only thing what we change, one is held with the copper, another one is a plastic. So what might be a reason? What could be a reason why the first reaction is faster than the second reaction? Or with a copper is faster? The only difference is we use copper here and we use a plastic. So what might be a reason for that? The reason is the copper act as a catalyst. That's why the reaction is fast. So experiment in which the magnesium held by a copper, the copper is acting like a catalyst. Copper does not react with dilute acids. Copper can react with concentrated acids. That's why here copper is not reacting. If copper was reacting, the amount of hydrogen should be more because copper is also reacting and magnesium react. But in this case, the copper is not reacting. It only acts as a catalyst. And transition elements and their compounds can be used as a catalyst. Experiment was repeated using 1 mole per dm cube of propanoic acid compared to hydrochloric acid. And propanoic acid is a weak acid. How would the graph of a propanoic acid will differ? Because weak acid reacts slower. So what will happen? How the graph will differ? It will be less steeper, or it will take more time to complete. And how the graph would be same? Because we are using a same concentration of the two reactants, the two acids. If we use the same concentration, what will happen? We'll have the same amount of hydrogen or same amount of a product. So amount of product or amount of hydrogen does not change because we use the same amount of acids. The only thing what happened, because propanoic acid is a weak acid and weak acids react very slow. As a result, what will happen? It will take much longer time for a reaction to complete, or the slope of this line will be less steeper. Is it clear, this one? Anyone having a doubt or a question till this point? Then give two factors which will alter the rate of a reaction, and for each factor explain why it alters. Like here we are reacting, a magnesium is reacting with hydrochloric acid. That's the original experimental procedure. Like magnesium is reacting with hydrogen. What changes we can make or do for this procedure so the reaction will be faster? Like we can alter here means like we can change. So what else? What I can do? What factors can be changed? It can be anything because demands alter. Alter means you can increase or you can decrease. Alter means change. What I should change? So surface area, temperature, concentration, concentration of the substance, surface area, temperature you can mention. So if I mention, like example, temperature, if I mention temperature, then increase the temperature, faster rate will be there, more collision, greater collision frequency. And I can also mention powdered or surface area, catalyst can be used. Not concentration, light or catalyst. The concentration, all why? Because two factors which alter the rate of this reaction for it. Yeah. Because concentration, they already mentioned some related to concentration of this in the beginning of question. So you can mention temperature can be changed. You can mention surface area can be changed. And if you change the temperature, what will happen? Greater. So what is explanation? It will have a like kinetic energy increase. As a result, kinetic energy increase, the speed increase. And when the speed increase, more higher collision frequency. And as a result, what will happen? Greater number of the particles have energy more than activation. So greater proportion of the particle with energy more than activation. Surface area, when you increase the surface area, as a result, when you use a powdered form, it will have a large surface area, so there will be more collisions. Greater the number of the collisions, greater the rate or the speed of a reaction. So this was an exercise related to rate or a speed of a chemical reaction. Today we did about 7 structure questions, almost half of the exercise. The whole exercise is having 14 questions. So we did 7 out of 14. So half of this exercise I have solved with you. Remaining half you will solve as a weekly homework next week.